Welcome to the second lecture on Module 3 of the course Introduction to Mobile Robotics. Before we begin today's topic, let us recall that in mobile robotics, sensing alone is not sufficient. Once a robot senses its environment, it must respond accurately, and that response is made possible by actuators. Among actuators, servomotors play a very critical role because robotics applications demand precision, accuracy, and controlled motion, not just rotation. In this lecture, we will understand what a servomotor is, how it works, its types, and where it is used, especially in robotic and control system. Servomotors are also known as control motors. They are mainly used in feedback control systems as output actuators and are not meant for continuous energy conversion like ordinary motors. A servo motor can be either a rotary actuator or a linear actuator, and it allows precise control of position, speed, and acceleration. Although the basic operating principle is similar to other electromagnetic motors, the construction and mode of operation are different, as servo motors are designed specifically for controlled motion rather than continuous rotation. One of the most important characteristics of the servo motor is its low rotor inertia, which allows it to respond very quickly. The rotor usually has a long length and small diameter, which further reduces inertia. Servo motors can operate at very low speed and in some cases even at zero speed, while still producing torque. Their power rating ranges from fractional watts to a few hundred watts. Because of low inertia and fast response, servo motors are ideal for position control applications in robotics. Servo motors are broadly classified into AC servo motors and DC servo motors. AC servo motors are further divided into two-phase AC servo motors and three-phase AC servo motors. This classification is mainly based on the type of power supply and application requirements. Each type has its own advantage, and the choice depends on power level control, accuracy, and application complexity. Now we will see the details about a DC servo motor. DC servo motor are either separately excited DC motors or permanent magnet DC motors. In a separately excited DC servo motor, the armature winding and the field winding are energized independently. The diagram shows the armature MMF and the field MMF are placed in quadrature, which improves control characteristics. This structure makes DC servo motor highly suitable for precise control applications. One major advantage of DC servo motor is their fast torque response. Since torque and flux are decoupled, even a small change in armature voltage or current results in a significant change in speed or position. Most high-power servo motors are DC servo motors. The torque speed characteristics has a negative slope which provides inherent viscous damping, improving system stability in servo drive systems. Now we will see the working of a AC servo motor. AC servo motors are classified into two-phase and three-phase servo motors. AC servo motors as already discussed. Most commonly, AC servo motors are two-phase squirrel cage induction motors used in low power applications. For high power requirements, three-phase squirrel cage induction motors are used as servomotors. AC servomotors are preferred where ruggedness and low maintenance are required. Now we will see what is the difference between AC and DC servomotor. The key difference between AC and DC servomotor lies in their control complexity, power handling, and performance. DC servomotor provides better torque control and faster response, making them suitable for precision tasks. AC servomotors are more robust, require less maintenance, and are preferred in industrial environments. Hence, the selection depends on accuracy, cost, power, and application needs. Now we will see the different applications of servo motors. Servo motors are widely used in radar system and process control systems where accurate positioning is required. They play a major role in computers, CNC machines, and robotics, especially for joint control and wheel actuation. They are usually used in machine tools, tracking system, and guidance system, where controlled motion is essential. In mobile robotics, servo motors enable precise steering, arm movement, and sensor positioning. With this, we have completed the details about the actuators. Now we are going to see the control system part, that is controlling the actuators, which is a major input or impact on the actuators. Thank you.